minus x equals to minus 5. We divide both sides by minus 1. Minus x divided by minus 1. Minus 5 divided by minus 1 is minus cancel this. So x equals to minus cancel this, and x equals to 5. So we go to our option C, the one that correlates with that, and that's option D. Then this number 15 question says that if this is equal to this, find the value of x. This one is very direct. So we have to look for the determinant of x, 3, 2, 7, and the determinant has been given to be what? 15. So just cross multiply. This times this, that's 7x, minus this times this, that is the way to look for the determinant. That's 6 equals to 15. Then 7x equals to 15 plus 6. 7x equals to 21. So we divide both sides by 7. 7x divided by 7, 21 divided by 7. 7 here 1, 7 here 3. 7 here 1, 7 here 1. So our x equals to 3. So we go to our option and see the one that matches that, and that is option D. Then the 16th question says that if P is this, what is the P raised to power minus 1? That's P inverse. So we have to calculate that. Owing to that if a matrix A equals to A, B, C, D is given, then our A inverse will definitely be 1 over the determinant of A multiplied by A minus. So in that situation, we now have our P to be equals to 2 minus 3, 1, 1. So what do we do first? Calculate the determinant of P. So we'll cross it. So that will be 1 times 2, 2 minus 3 times, minus 3 times 1, minus 3. So logically it will be, our determinant will be 2 plus 3, and that is, our determinant is now 5. Now we have P inverse automatically will be 1 over 5 into, where is our P? Our P is 2 minus 3, 1, 1. So in that situation, we interchange the leading diagonal. We have 1, 2. Then we subtract the other diagonal, minus 1, minus 3. So automatically we are going to have P inverse will be 1 over 5 into 1, minus times minus plus. So that's 3 minus 1, 2. Then this, we can leave the answer this way. Sometimes it is good to leave the answer this way, but according to the option given to us, we discover that the answer is not left this way. So what we need to do here is to say P inverse will now be 1 over 5 times this. We have 1 over 5 times 1, then 1 over 5 times 3. We are using 1 over 5 to multiply each term in the bracket. So you have 1 over 5 times minus 1, 1 over 5 times 2. That's what it means. At the end, we are going to have P2, P inverse to be 1 over 5 times 1, that's 1 over 5. 1 over 5 times 3, that's 3 over 5. 1 over 5 times minus 1, minus 1 over 5. Then minus 1 over 5 times 2, 2 over 5. So we'll go to our option and see the one that correlates with that. 1 over 5, 3 over 5, minus 1 over 5, 2 over 5. 1 over 5, 3 over 5, minus 1 over 5, 2 over 5. So it's definitely the option D. Inequalities. Under this topic, candidates should be able to solve problems on linear and quadratic inequalities, both analytically and graphically. So let's look at the inequalities. So we have linear and quadratic. Linear is when the degree of your variable is 1. For example, 2x plus 5 less than 0. This is a linear inequality. Linear inequality is this because the power of our x here is 1. So we are expected to get one value for x. That is why it is linear. But if it is quadratic, it follows this pattern. Ax squared plus bx plus c is less than 0, and you can have it ax squared plus bx plus c is greater than 0. So you can have these two or these two dimensions. Now in this situation, you have a case of the first one. Let's say our constant is a is 1. So you have x squared plus 5x plus 4, for example, less than 0. Or you have x squared plus 5x plus 4 greater than 0. So this is quadratic in the sense that the highest power of our x or variable is what? 2. So we are expected to get 2 values in this respect. When a is greater than 0 and when a is less than 0. So if you have a situation like this where our a is greater than 0, if our a is greater than 0, we have a minimum curve of this kind. That's when our a is greater than 0. Then when we have our a less than 0, so we have a maximum curve to come this way, where these are the 2 points where the curve cuts the x-axis. This is our x-axis, this is our y-axis. This is our x-axis, this is our y-axis. So it is very pertinent to note this curve because that will form the fundamental in solving questions under inequalities. So in a case where you have a polynomial such that ax cubed plus bx squared plus cx plus d, for example, or in this situation, and if our a is greater than 0, so we are going to have a scenario like this. We are going to have a scenario where this is our y-axis and this is our x-axis. So that's when our a is greater than 0. Then when our a is less than 0, so we are going to have a condition of this kind. Or let me put it like this, since it's going to pass through the origin. So let me put it like this. It will come this way, intersecting like this. So where this will be our x-axis and this will be our y-axis. So the explanation on this is that the shape, because we are going to be using graphical and analytical method. Using our analytical and graphical method. So in this situation, that is why it is very good to note the shape of our curve, so that by the time we start using this graphical method, it will not be confusing. So we are going to look at 12 UTME questions designed for this topic so that we can appreciate the use of graphical method. Or let me quickly cite an example where the use of graphical method is of significance. Now, if a question asks us to solve, let's say x squared minus x plus 2 less than 0, or we have x squared plus x minus 2 greater than 0. So if you have a scenario like this, what are the factors of 2? We have 2 and 1. We have 2, 1. So in this situation, the only condition that I can have this is when we have plus 2 as plus 2x and x. Then this condition you have minus 2x and what? X. Minus 2x and x. So let's see how we can use the graphical method to solve this particular problem. So in this situation, if you are to consider the first one, x squared minus x plus 2 is less than 0. So in this situation then, I know that I will use this to multiply this, whereby I will have plus 2x squared. This one will not even work. So let's try this second one. Let's use the second one. The condition, a case where we have x squared plus x minus 2 less than greater than 0, or x squared plus x minus 2 less than 0. So I want to show you how graphical method can be used to solve questions like this in the shortest possible time in the exam. So in this situation, if you have a scenario like this, so just pick it x squared plus x minus 2 less greater than 0. So I'll use this to multiply this. So I'll have minus 2x squared. So I'll look for the factors. Now, what are the factors of my 2? You have 1 and 2. Then the one that will give us in the middle will be plus 2x minus x. So in that situation, anywhere I see x here, I will replace with what? Plus 2x minus x. So in that situation, I will have x squared